This podcast episode is going to look at how we look at bonding through atomic stability. We described in class that an atom is chemically stable when its outer energy level is complete. By looking at the periodic table, we see some consistent patterns on how some of these elements do react with each other. Also, as we described in class, we can look at the periodic table and we can see some trends. All of the elements that are found in the first column, which we call group 1, also the alkali metals, they all contain one electron in their outermost shell. The trend continues as we continue across the periodic table. Everything in group 2, the alkaline earth metals, contains 2 electrons in their outermost shell. In group 3, they contain 3 electrons in their outermost shell. Group 4, 4 electrons in their outermost shell. Group 5, 5 electrons in their outermost shell. 6, 7, and until you get to the noble gases in group 8. The noble gases do not react because they have a full outer shell. They do not make compounds. They are electrically stable. Look at the electron configuration to figure out how stable atoms are. Let's start with hydrogen. Hydrogen is found in the first row, first column of the periodic table. This tells us, because it's in the first column, that it has 1 electron. To create an electron dot diagram of hydrogen, we draw 1 electron. Now to complete that energy shell, hydrogen needs to find 1 more electron to be more like helium. When bonding, you can have 2 hydrogen atoms together, bonded. This is through a covalent bond. It looks something like this, where 1 electron from one hydrogen atom will spend time around the other hydrogen atom, filling the outer shell of the hydrogen atoms. Let's draw another atom. Let's draw magnesium. Note that magnesium is in the third row, meaning, third period, that it's got 3 energy levels. Again, when we're looking at creating an electron dot diagram, we're looking for the valence electron, or the amount of electrons in its outermost shell. And magnesium has 2 electrons in its outermost shell. Looking at oxidation numbers allows us to think about whether or not this particular element would gain or lose electrons. Note that magnesium, being an alkaline earth metal, would have an oxidation number of 2+, meaning that magnesium would become a positive 2 ion, giving up 2 electrons in an ionic bond. Now let's draw an electron dot diagram for chlorine. Chlorine is found in the third period, and it is in the 7th row. That tells us that chlorine contains 7 electrons. That's 7 valence electrons, leaving chlorine with 1 empty spot to be more like argon.